once again to this channel. Here we are going to have a continuation of the concept of probability with examples. So starting with this example 1, and as you know, in our previous section we discussed some key terms under probability, including the probability itself, where we said that probability of an event, example E, event E is the number of sample points in the event divided by the number of sample points in the sample space. That is the number of elements in the event divided by the total number of elements in the sample space. Good. So here we have an example. An example says that a fair die is thrown once. What is the probability of obtaining A, an even number, B, a number greater than 2, C, a number between 2 and 5? So let's solve this together. So to solve this, first of all, we will have to find the sample space for throwing a fair die once. So if you throw, or if a fair die is thrown once, the sample space, let's represent it with capital X. The sample space for throwing a fair die once will be 1, 2, 3, 4, 5, 6. So this will be the sample space for throwing a fair die once, because these numbers are on a die, and so they are all possible outcome for throwing the die once. And so if it's the sample space, then we then come and find the number of elements or the number of sample points in this set sample space. So the number of elements or the number of sample points we have there are how many? 1, 2, 3, 4, 5, 6. So there are 6 sample points. In other words, there are 6 elements in that sample space. So having found that, then you then come and find even numbers. So A, you come and find set of even numbers. So let's represent set of even numbers to be capital E. So even numbers. So you look through here the sample space to fish out the even numbers or take out the even numbers. So the even numbers from these will be 2, 4, and 6. This is the set of even numbers. And so if this is the set of even numbers, then we come and find the number of elements in this set. So how many elements are there? 1, 2, 3. There are 3 elements. In other words, there are 3 sample points in that set of even numbers. So having found that, we then come and find the probability. So the probability for obtaining an even number, will be equal to the number of sample points in even number, that is the number of elements in even numbers, divided by the number of elements in the sample space. That's the number of elements in the set of even numbers here, divided by the number of elements in the sample space. So this will be equal to the number of elements in the set of even numbers. There are 3. So we have 3 divided by the number of elements in the sample space. There are 6. So we have 6. So this will give us 1 divided by 2. So if a fair die is thrown once, the probability that you obtain an even number will be 1 out of 2. That's 1 divided by 2. B. So we come to B. B, a number greater than 2. A number greater than 2. So let's represent this G2 to be number greater than 2. So let's get the set of numbers greater than 2 from the sample space. So set of numbers greater than 2 will start from 3. So we have 3, 4, 5, and 6. These are the set, or this is the set of numbers greater than 2. So we then come and find the number of elements in this set. So how many elements are there? 1, 2, 3, 4. We have 4 elements. We have 4 elements. So if there are 4 elements, then come and find the probability of that. So probability of obtaining a number greater than 2. Probability of obtaining a number greater than 2 will be the n of numbers greater than 2 divided by the sample space. We have n of numbers greater than 2 divided by the number of elements in the sample space. So this will be equal to n of elements greater than 2. There are 4 divided by the number of sample space, which is 6. So this will be equal to 2 divided by 3. So if a fair die is thrown once, the probability of obtaining number greater than 2, a number greater than 2 will be 2 out of 3. Then let's come in. So see, the last question under that, we have a number between 2 and 5. Let me write this one. A number between 2 and 5. So let's use this symbol to represent a number between 2 and 5. So let's find the set of this number between 2 and 5. So we have numbers between 2 and 5. So from 2 we have 3 and 4. This is a set of numbers between 2 and 5. So we'll come and find the n of numbers between 2 and 5. That is the number of elements in the set of numbers between 2 and 5. There are how many? 1 and 2. So there are 2 elements. Then we then come and find the probability of numbers between 2 and 5. Probability of numbers between 2 and 5 will be n of numbers between 2 and 5 divided by n of the elements in the sample space, or the number of elements in the sample space. So now we have this n of numbers between 2 and 5 is 2 divided by the number of elements in the sample space. They are set. So this will eventually give us 1 out of 3, or 1 divided by 3. So probability of obtaining a number between 2 and 5, if a fair die is true, is 1 out of 3. And so this is the solution to this example. And so if you are convinced with this explanation, we want you to subscribe and share our content for more interesting videos under the probability. Bye bye.